Assalamualaikum warahmatullahi wabarakatuh, and hello, my name is Muhammad Nurafiz bin Zulkifli with Magnetic ID AE190016. So for the first question for the lab 9 is used to record the voltage AC supplies VR1 and R1 using the oscilloscope. So this is the circuit that we need to stimulate and record. So this is the circuit we use in the software multisim. This is the source with the voltage value 14.6 volt and with frequency 50. And the load is resistor 100 ohm, and the second load is 1000 ohm. So in order to get the result for the oscilloscope, we need to run the simulation and then stop at the anyways time. So here we can determine what voltage that we need to see. Here we need to determine the lowest and the highest for in the waveform. So this is how I get the VP. So this is for the VAC source. I got the value is 14.592 volt for the positive side and for the negative side. This goes for the same for the R1 and R2, which is have the same method. We need to determine the lowest and the highest part of the waveform. Use the same method, and we got for the R1, which is 1.326 volt. Same for the positive and negative side. And lastly, also same for the VR1, which have 13.261. So we can see here the value for the VR1 is almost the same with the VAC source, because it was placed in a parallel condition while the R1 is in series. So we can expect why the value is small. So that's all for the simulation. Thank you.
Hi and Assalamualaikum. So now we will continue for activity 2. So in activity 2, we will need to adjust the variable resistor to 200 ohm value. So we will need to, after we adjust the value, we will need to observe and record the voltage across the VR1 and R1 by using the oscilloscope. So let's move into the design circuits. So here are the circuits that are designed in the multisim software. So we need to adjust the variable resistor. So just vary it to 20%, which means that 20% of the 1 kilo ohm means that it has 200 ohm value of resistor. So now let's simulate the circuit and see the oscilloscope. So here are the waveform for both R1 and VR1. The red one represent the R1 waveform, while the yellow one indicate the VR1 waveform. So we can hear that the VR1 have a higher voltage than the R1. So to calculate it, so we need to see the scale. So the one division, which means one box here, represent 5 milliseconds, which are the x-axis. and the y-axis represent for voltage. So one division, which means one box, means 5 volts. So we can see here that R1 is having not more than 5 volts, and the VR1 is less than 10 volts in the oscilloscope. So for the actual value, we can move the cursor to see the actual value for these two waveforms. So we can see here that the peak voltage for the peak voltage across the R1 is around 4.842 volts, while the peak voltage around VR1 is 9.685 volts. So that's all for activity 2. Thank you.
Assalamualaikum, I am Muhammad Afid bin Ahadul Nisam. My metric number is AA190052. So I will explain about activity 3, which is for question 1, using the equation P equal to VI cos theta, we have to calculate and record the power dissipated by the circuit. So given in the circuit, the voltage is 14.6, the resistance is 100. So using the Ohm's law, I equal to V over R. So we got the current is 0.146 ampere. So for the angle is 0, and after we insert the values in the formula, which is P equal to VI cos theta, 14.6 is the voltage, I is the 0.16 ampere, and cos theta is cos 0. So we have 2.13 watt. So for activity 2, using the equation of power equal to voltage square over resistance, we have to calculate and record the power dissipated by resistor R1. So here we have the voltage the same, 14.6, and the resistance is 100. And also we got the power is 2.13 watt. So for the next question is, using the equation P equal to I square R, we have to calculate and record the power dissipated by the resistor R1. So insert the value of I, which is 0.146, and the resistance is 100, and we got 2.13 watt. So for the last question is, do all power values agree? And the answer is yes. That's all for activity 3.